This conference will now be recorded.
Hi guys, good evening. Yes, can you hear me? Hello. Yes, guys, can you hear me? Yes, thank you. Yes, today's topic is OOPS concepts. Let us see. Yes, what is OOP? OOP stands for what? OOP stands for yes, objects, yes, oriented programming, object oriented programming. OOP stands for objects oriented programming. OOP stands for objects oriented programming. Okay. Yes, exactly what is OOP. OOP is a concept, it's not a language. OOP is just it's a concept. It's a concept. OOP is a concept. OOP is a concept. Yes, it is not a language. It is not a yes, it is not a language. OOP is not a language. Okay, there's a concept here. Yes, OOP is a concept. It is not a language. OOP is a concept. It is not a language. Okay. Yes, why OOPS concept was the first of all, what's the reason? Yes, what is the reason? What's the reason? What's the reason to develop yes OOPS concepts? What's the reason to develop OOPS concepts? What's the reason to develop OOPS concepts? What's the reason? Okay. Yes, what's the reason? What's the reason to develop OOPS concepts? Let's see. Yes, before OOPS, there is a C language. We have C language. C is the first high level language. C is a first high level language. Okay, C is a first high level language here. First high level language. C language. Before OOPS, there is a C language. C is a first high level language. See, in C language, everything is global. Yes, here in C language, everything is global. Yes, everything is global. Everything is global. Everything is global. In C language, everything is global. Everything is global. Yes, like functions and data. Functions and data all are global here. Functions are global, data global. Okay. Yes, next. Here in C language, since functions are global here, global functions. Functions. Any function, yes, any function, yes, can be called. Any function can be called from anywhere. Any called from anywhere. Any function can be called from anywhere. Anywhere. Any function can be called from anywhere. In C language, everything is global, like functions and data. Functions global, data is global. Any function can be called from anywhere. Okay. Next, data. Data also global. Data also global. Okay. Yes, it can be. Yes, data also can be. It can. Yes, yes. It can be accessed. It can be accessed from anywhere. From anywhere. It can be accessed from anywhere. Anywhere. And also can be modified. And also can be modified. Yes, modified from anywhere. Anywhere, right? Anyone can modify from anywhere. You can modify from anywhere. You can do that here. Data can be modified here. Okay, data is global, functions global, everything is global. For example, here, yes, let me show that practically here. Suppose main function, C language main function starting ending, main function starting ending. Yes, function 1 starting ending. Okay, suppose function 2 starting ending. There are some functions like this. There are some functions. Okay, main function. See, suppose int a equal to 10. In main function, okay, int a equal to 10, initially 10, next a equal to 20. Yes, we can change it. Next a equal to 30. We can change that value, right? We can change it. So initially a value 10, later 20 assignment, next 30 assignments. So 20 assignment, 30 assignment, right? So we can change these values. Suppose same a I wanted using function 1. Yes, A equal to. Yes, A equal to some 40. Yes, not valid. Not valid. See here, in software generally any technology here, if we declare here that can be used inside of this block only, local to that block. Suppose inside of this, I'll make it one more block, main function. Yes, not in C language anywhere. If it is block inside of the block, suppose int x equals some 50. Yes, this is local to this block. Local to this block here. This int x can be used only inside of this block here. Only inside of this block. We can't use outside. Suppose outside here, if we say like x equals 60, that is not valid. X equals 60 is not valid. Scope of this x is inside of this block only. I can't use here. X equals 60, not valid. Not valid. That is not valid. Okay, right? Suppose here one more block. One more block. Suppose in this block here, suppose int, yes, int y equal to some 40. Int y equal to 40. Yes, this y you can use inside of this block only. We can't use outside. Suppose y equal to 60, that is not valid. Yes, y equal to 60 is not valid here. Not valid. You can't use. You can't use. It's invalid one. This is not valid. Okay, it's not valid. Okay, right? Yes. So scope is within this block only. This scope is within the block only. Now this case, suppose A equal 10. Yes, what is scope of this A here? Inside of main block only. We can't use from anywhere, correct? We can't use from different locations. Declare inside the main function. Yes, we can use inside the main function only. We can't use outside. Local to this main function. Suppose same A I want to use in function one also. Not valid. You can't. Suppose same A here A equal to some 50 here also. Not valid. Not valid. Suppose really if you require, yes, to use in function one, function two. That A using instead of function one, function two, right? That case, same A should be declared at the top of above the main, at the top of the paragraph. Yes, if you declare above the main here, this A you can access instead of main function. From the function one, from the function two also you can access. Okay, if not all these functions here, other functions also can access. Yeah, this data is called global data. It's a global variable. It's a global variable. It's a global data that you can access from main function. You can access from function one. Yes, you can access from function two. Not all this here. Suppose one more function. Suppose function 4. From the function 4. Yes, suppose function 5. Like this, many number of functions. Many number of functions. Suppose here in project development, yes, in main function requires function 1 required, function 2 requires. But by mistake, if we try to change a value instead of this function 4, yes, that will compile, it will execute changing values. Suppose function 5, suppose a equal to suppose some 90. Yes, this is also valid here. All these statements valid because a is a global variable. A is a global. That A is global. You can access from anywhere. From main function you can access. From function 1 you can access. From function 2 you can access. From function 4, function like from all the functions of applications you can access. But requirement is only in main function, function 1, function 2. Only these functions. Only these three functions. But once you declare as global here, that you can access from anywhere. Anywhere. Fine. Suppose calling main function, a value changes to 20. Next, a value changes 30. Suppose whenever calling function 1 changes to 40. Suppose calling function 2 changes to 50 here, right? Okay. Yes. Here, function 4, function 5, by mistake, this is a equal to maybe developer mistakes, something else. A mistake here. By mistake, if you try to change this value, that will change here. That will be changing because function 3 may be calling from anywhere. At any time calling function 4 because functions are global. That function may be calling from other module also, from different modules also you can call that function here. So whenever call to function here, a value changes to 70. Suppose calling function 5, a value changes to 90, right? So by mistake that values are changing, right? By mistake data is changing, right? So what is happening here? So actually expected value is 10 or 20, 30 or 40 or 50, but this is not expected, unexpected. Okay, so overwriting 70, overwriting 90 here. So expected for 10, 20, 30, 40, 50, but getting 70, 80 here, 79, right? Unexpected, nothing but it's a bug that leads to bugs. Data corrupting, data overwriting. So since it's a global data overwriting, right? Data overwriting. So there is no security for data in C language. That is C language concept. There is no security for data. There is no security for data in C language. Okay. Yes. To achieve data security, one second. One second. Yes. So data is global. That you can access from anywhere here. So there is no security for data in C language. To achieve data security, here, simply hit this A, starting, yes, making some block A, next main, I guess making some block, just making some block like this. Okay. Next, this is making some separate block. Next, closing this block, right? Okay, just now we discussed once a block is created, that is local to that block only. Suppose main block. Here is a main block, function block, function to block. Okay. Yes, on top of which one more block is there. This block starting ending. Block starting ending. That means what is the scope of this within this block? You can't access from these functions. Okay. So you can in this block here, data and functions both are placed in same block, right? Same block. Now from the main function you can access here. From function 1 also we can access here. Next function 2 also we can access. From this also we can access. So because this data within the block. Now inside of this block, data and functions. Now these functions can access this data. These functions can access this data here. Okay. See, these functions cannot access. They're outside functions. Outside things here. Here block started ended, right? Okay. So now these are inside of same block. In the same block, right? Now same block functions can access. This A can be accessed in this block here. Starting block, ending block, right? Yes, inside this from anywhere you can access. So this data is limited to only these three functions, right? So there is a security for data. Okay, only these three functions can access this data, right? Yes, outside functions cannot access this data. Okay, they are defined outside. Now inside of this block, yes, inside of this block here, A is there and functions are there. A is there, functions are there. Only these three functions can access this key here. Suppose one more variable, suppose int b. Yes, int b equals some 5. Okay, these variables also you can access from these functions here. From outside functions cannot access. That means this data is binded to only these three functions. We cannot access. Such kind of preparation is nothing but encapsulation. Here this block is nothing but a class. It's a class. Suppose some class. Class test. In this A and B here, next there is a main function, function 1, function 2, something like this. Okay, right? So this data is now limited to only these three functions. Okay, cannot access from other outside functions. There are outside functions. This kind of preparation nothing but encapsulation. So you get these are data and these functions, right? Okay, so data and functions bind it as a single unit. Okay, yes, binding of data and functions as a single unit called as encapsulation. So only these functions can access this data A and B here. Yes, outside functions cannot access. So security for data. So this is not valid, this is not valid. So security for data. This is called as encapsulation. So first one, concept. First one is encapsulation. What is encapsulation? Yes, it's a binding of data and functions. Binding or wrapping, like a chocolate wrapper. We are wrapping chocolate, right? Like a chocolate wrapper. Yes, it's a binding of data and functions as a single unit. Yes, encapsulation. This process is nothing but encapsulation. Yes, binding of data and functions as a single unit. That unit is nothing but class. By defining class, you can bind the data to particular functions here. Okay, only these functions can access. For example, prepare like this. Yes, only function 1, function 2 can access this ENB here. Outside functions cannot access because block started here, ended here. Inside of this block, inside this block here, data is there, and functions are there. Only these two functions can access this ENB here. Others cannot access. This concept is nothing but, yes, yeah, data means variables. This A and B are variables. They're variables. So A is contains some data, B contains some data. These variables you can access from only function 1, function 2, not from outside functions. This concept is called encapsulation. Okay. So first initially OOPS was dealt with encapsulation. So what is encapsulation? It's a binding of data and functions as a single unit, or wrapping of data and functions as a single unit is called as encapsulation. Yes, what is purpose of encapsulation? Just hiding data. With encapsulation, just we are hiding data from the outside environment. Just hiding data. Yes, purpose of encapsulation is data hiding. Data hiding means is data abstraction. Okay. Yes. See, first of all, what is encapsulation? Yes, encapsulation. What is encapsulation? Yes, it's a binding of data and functions. As a single unit. Yes, it's a binding of data. It's a binding of data and functions. As a single unit called as encapsulation. Okay. Yes. What's the purpose of encapsulation? Data hiding. Purpose is data hiding. Here. Purpose. Yes. Purpose of encapsulation. Purpose is data hiding. Right? Data hiding. Okay, data hiding is nothing but data abstraction. Next one, data abstraction. What is data abstraction? Yes, data abstraction. Abstracting data. Data abstraction. So what is data abstraction here? Data abstraction. Yes, it's a hiding data from outside environments. It's outside environment. It's hiding data from the outside environment here. Data abstraction. Yes, it's a hiding data from the outside environment called data abstraction. Okay. Yes, purpose of encapsulation, data abstraction is achieve data security. These two features are to achieve data security. Right. Okay. So encapsulation, it's a binding of data and functions as a single unit. That unit is nothing but a class. Okay. Or you can say wrapping of data and functions. Okay. Yes, purpose is to hide data. To hide data here. Purpose is for hiding data. Purpose is for hiding data. Data hiding called as data abstraction. What is data abstraction? It's a hiding data from the outside environment here. Okay. See, data abstraction can be achieved through the encapsulation. Data abstraction means hiding data. Data abstraction means hiding data can be achieved through the encapsulation. Yes. Okay. Yes. Main purpose of these two features is to achieve data security. Main purpose of these two features to achieve data security. So initially, OOPS concept was introduced with these two features. Later added many features like method overloading, method overloading, Okay. Yes, like method overloading. Next, constructors. Yes, next constructors. Next, inheritance. Yes, next polymorphism. Yes. So encapsulation, data abstraction. Next, method overloading. Next, constructors. Next, inheritance. Next, yes, polymorphism. Yes, polymorphism. Inheritance, polymorphism. polymorphism. Yes, next. Yes, method overriding, method overriding, method overriding, method overriding, method overriding, method overriding, method overriding. Next, operator overloading, operator overloading, operator overloading here, operator overloading, method overriding. Next, operator overloading, operator overloading. Yes, next, yes, method overriding, operator overloading, polymorphism, inheritance, constructors. Yes, data encapsulation. Yes, yeah. Next, generic nature, genericity, generic nature. These are the, yes, one more, 10th one, distractors missing. This is, yeah, distractors, distractors, distractors. These are the features of Hoops concept. Okay, they are all features of Hoops concept here. Okay, generic is not a template concept, just a template concept. In C++, you can implement this one here. It's a templates concept, templates concept in C++. Okay, these are the features of Hoops concepts. Okay, initially oops was introduced with encapsulation and data abstraction. Oops was developed. Initially oops was developed with encapsulation, data abstraction. Later added all these features like method overloading, constructors, inheritance, polymorphism, method overriding, next operator overriding, templates, and destructors. But Java does not support all these features. Java supports encapsulation, data abstraction, method overriding, constructors, inheritance, polymorphism. Next, method overriding also okay. Okay, these will not support. Java does not support these features, except which all are supporting. So Java is OOPS language. So any language which is supporting main features of OOPS, any language which is supporting main features like encapsulation, data abstraction, method overloading, yes, inheritance and polymorphism, they are main features. Any language which is supporting that all that 5 features, that is called as OOPS language. Java is a OOPS language. Reason supports the main features of OOPS concept. Okay. Yes, we'll see one by one. So what is data? What is encapsulation? Yes, definition, data abstraction. Okay, fine. Correct? Yes. Now let us start implementing encapsulation, data abstraction. See, later these things we'll discuss. Chapter wise we'll discuss. Okay. Here I can explain definition. Theory concept I can explain. Okay, unnecessary wasting of time. Yes, we'll be discussing again in actual topic. What is method overloading? What is constructors? What is inheritance? That time we'll discuss. Okay. Now, first, how to implement encapsulation and data abstraction in Java. Okay. So implementing encapsulation and data abstraction in Java. How to implement? For this, classes and objects are required. Classes and objects. So first topic is classes and objects. Let us start. Classes and objects. Okay. Yes. 1 second. Let me open Java documents. One second. Yeah, this is what topic. So previous one all this discussed. Yes, that methods of the OOPS concepts. See last class topic once again. Last class, right? Swapping technique with methods. Call by value, call by reference topic discussed. Okay, now OOPS concepts. OOPS. Yes, object oriented programming was introduced to overcome the disadvantage of C language. Disadvantage, C language disadvantage. In C language, everything is global. Data and functions are global. Data can be accessed from anywhere in the application. Any function can be called from anywhere. Since everything is global, there is no security for data. Chance of corrupting data in C language. Yes, OOPS concept was introduced to achieve data security. Yes, what is OOP? OOP is a concept, it is not a language. It provides following features like encapsulation, data abstraction, main features. Main features of OOPS here. So any language, yes, which supports all the above features, that language called OOPS language. Example, first one is C++. 1 second. First OOPS language. C++, next is Python, next VC++, next Java, .NET, and then Scala. Okay, so what is encapsulation? Yes, it's a binding of data and methods in a single unit. In C language, calling as function, same thing, Java it's a method. Java it's a method. Okay, see, purpose of encapsulation is to achieve data abstraction, is hiding data. What is data abstraction? Yes, it's a hiding data from the outside environment. Yes, it can be achieved through the encapsulation. Yes, purpose of data abstraction is to achieve data security. These two features, encapsulation, data abstraction. So mainly these two features are to achieve data security, Right, okay. Yes, next method overloading from definition here, constructors, inheritance, formalism. Later we'll see. Wasting of time here, later we'll see. Yes. Loops first chapter is classes and objects. Classes and objects here. Okay. Yes, let us see what is a class. How to define a class. Suppose employee information. Employee information. So how to define a class for employee information? So public class employee, public class employee, class starting ending. Correct? Yes, employee. See this, suppose employee number, int emp number, int suppose envo. Okay, suppose emp number. Next thing, yes, ename. They're the variables here. Yes, emp number, enumber variable, ename variable. Okay, yes, next, suppose, yes, double salary variable, double salary. Okay, so e number, yes, ename, double salary. Yes, suppose next string. Yes, about department dname. Yes, next, suppose string gender. Yes, gender. Next integer. Yes, something like this. So e number, ename, salary, dname, gender, and yes. Okay. These are employee information, right? Now this one tells about emp record. emp record contains what? emp number, emp name, salary, department name, gender, and yes. So employee. So now this class tells about information about employee details. What are the details here? Employee number, employee name, salary, department name, and gender, yes. So every record contains these details. Means now this one tells ID of employee information, right? ID of employee, that class says about employee information. It's an ID of employee information, right? This is nothing but class. Class is an idea of something here. Maybe class, it's idea of something like maybe employee information or student information, maybe some product information, maybe some orders information, some item, something like some information here. Just it's a idea of something here. Like a blueprint. What is blueprint? Blueprint giving some idea, right? So blueprint of some building. Before constructing, there's a blueprint, right? That blueprint gives the idea of building, right? Same. Just idea of employee records. Not this, just idea of employee information. It's nothing but class. So what is class? It's an idea of something or blueprint of something. Okay. Yes. Now this is just idea of employee information. Right. Okay. Now look at this class. directly will not acquire any memory here. E-number variable, E-name variable, these variables will not acquire memory directly here. When this acquires memory here, yes, when are creating objects, when object is created, then all the members of the class acquires memory. What is objects? What is class? What's the difference here? See, class just like a blueprint of building, right? Class is just like a blueprint of building. Okay. What is object exactly here? Yes, class is like a blueprint of the building. What is object? Object is like a building. Okay. See, blueprint means it's logical idea of building, right? Just is logical. Blueprint just is logical one. After constructing, you can see, you can feel physically. So building is a physical one. Before constructing is logical blueprint, right? So class is logical one. Object is a physical one. Once object created, all the members acquire memory physically. Otherwise, there is no memory for the class. Yes, class, this will not any acquire any memory directly here. When object is created, all the members of the class acquire memory. So when object is created, all the members of the class acquire memory. Otherwise, there is no memory for this class. It's a logical one. Class is logical one. Object is a physical one. Okay. So when object is created, for example, here, suppose employee objects, creating some employee objects, employee. Suppose E1 is equal to new employee, creating employee objects. Yes, when employee object is created here, new employee, when this object created, all the members acquires memory. Okay, all the members acquires memory in the same block, not different locations. But all are in the same block, not different locations. Okay, suppose if not of class, if we declare like this, individually declared here. Yes, this E number storing somewhere, E name storing somewhere, salary storing somewhere, D name storing somewhere, gender somewhere here. Yes, are different locations. They are different locations. Once you prepare like a class, yes, once like a class here. 1 second. If it is like a class, yes, public class, employee, public class, yes, employee, public class employee, starting ending. Correct? Yes. Employee rates. Yes, all the members acquiring at one location, like a single block, like a record format, Okay, 1 second. See, like a record format. One second. It's not there. Yeah, like a record format, like this, like a box, all at one place, Okay, all this data at one place, Okay, yes, all the members storing at one place, nothing but object here. Okay, so what is class? Class, it's the idea of something or blueprint of something. It's logical one. What is object? Object is a physical entity for the class. It's an instance of the class. What is object? It's a instance of the class. Is a physical one. Object is a physical one. Class is a logical one. Okay. Yes. Once object created, all the members of the class acquires memory. Once object is created, all the members of the class acquires memory. Yes, we'll discuss. I'll explain that memory map and all everything. I'll explain. Show that. Okay. So when object is created by all the members of class acquires memory. Okay. So object is like a record. Object is like a record. Okay. Object is like a record. Yes. What is the name of record? E1. E1 is the name of record. That E1 contains what here? Yes. Employee number, name, salary, department name, something like yes, something like this. Okay. So this object is a physical entity of the class. Object is a physical entity or it's an instance of the class. Okay. Right. See, let us go for this. See, document classes and objects. Classes, objects are required to implement encapsulation data abstraction. Okay, class is an abstract idea of something, a blueprint of something here. Defining a class. So public class sample, private integer, private float be something like this. Set data and display. So now this is class, right? Completely class is like this. Okay. Yes, in this here, See, yes, employee class. Suppose employee class is, for example, methods. Public set data is a method. Set data starting, ending. Okay, set data. Yes, public white display. Public white display. Starting method, ending methods. Okay. Now in this, now these all are called as data members or instance variable. Yes, exactly what is instance variable we'll discuss next. May not be understanding here. We'll discuss next. Okay. Yes, after finishing first example, I'll tell you. These all are called data members or instance variables. Data members to maintain data, to store data. Data members. These variables are called data members. They are data members. Don't say simply variables. Simply we can't say variable. Okay. Suppose if we declare variable local to methods int a equal 10. Now this a is local to set data methods. Now this is a is a variable. This is variable, but these things don't say variable. They're not variables. They're not variables here. Local is variable. Int a equal to, it's local to set data. So this is variable. Int a equal 10. Suppose instead of display, suppose int x equal to some 100. This is also variable. So this is variable. Local declarations are variables. This is variable. This is variable. But these things don't say variables. These are data members or instance variable. Don't say simply variable. Simply variable means a local variable. Variable means local variable. But these are what part of class means. These are instance variables. There are three types of variables in Java. Three types of variables: local variables, instance variables, class variables. Yet the topic later we'll discuss. This is not right time to discuss here. Okay. So these are local variables. These are instance variables. Next, class variables are different. There are some static variables. Static variables later we'll see. Okay. Now this employee number, name, salary, dname, gender, age. These are data members. These are data members. Next, set data and display their methods. These are methods. So data and methods. So data members are to store and maintain data. Data members are to store, maintain data. Yes, methods to update data. Suppose set data. So maybe changing values. Display methods, maybe displaying values here. Okay. So methods are to update your data. Maybe updating your data means modifying data, displaying data, some transactions here. Okay. So these are called data members. These are called data members. They're called methods. Data members are to store and maintain data. Methods are to perform some operations on data. Operations like CRUD operations. Methods are to perform CRUD operations like creating new data. Next, CRUD. One second. CRUD. What is exactly CRUD here? CRUD. CRUD means create. Next, read, create, reads, yes, update and delete, update and delete. Create, read, update and delete. Okay. Create, okay. Read, update and delete. Create, read, update and delete. Okay. So creating new data. Okay. Creating new data. Read means to read existing data. Update is to modify the existing data. Here, delete means to delete data. So nothing but CRUD operations. So with methods you can perform. The methods are to perform CRUD operations. Okay. Yes. Both the data and methods are comes under one class. Update is created. All the members of the class requires memory. All members. I'll show. Memory map. I'll show. You can understand. Memory map. I'll show. You can understand. Yes. Suppose, for example, let us see some example here. Suppose public class, suppose sample class, public sample, starting, ending. In this, some members like generally declaring data members are private. What's the purpose of private? I will explain. Page. Classes are public. In real-time projects here, real-time classes are public. Data members are private. Data members always is private. Rare case using non-private members, always private. private int a. What's the purpose of private? I will explain. Wait. Yes, next private int b. Private int a int b. Private int a int b. Okay. Next public void set data. Public void set data. Yes, set data methods, some code. Okay. Next public void display some code. Yes. Okay. Display some code like this. Now in this A and B, they are the data members. Okay. Set data display methods. Data members to maintain data. Methods are to update data, means performing some transaction data here. Methods are to perform some transactions, means like CRUD operations. Okay. So this is defining a class. Right? Next part is how to create objects. Creating objects. Sample S1 equal to new sample. 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 So creating objects. Suppose if you want to create one S1 second. First declare, next later creating objects. Sample S1 declaring objects. Yes, S1 equal to new sample. So declaring S1 equal to new sample. This is one way, or else both at a time here. Sample S2. Suppose S2 is equal to, in single statement you can write sample S2 equal to new sample. Correct? Next sample S3. Sample S3 is equal to new sample. So S1 equal to new sample, S2 equal to new sample, S3 equal to new sample. S1 equal to new sample, S2 equal to new sample, S3 equal to new sample. Correct? This is way of creating objects. Right? Okay. See, when object is created, all the members of the class acquires memory. All the members means data and methods. Methods are also part of objects. Every object contains both data and methods. Every object contains both data and methods. So here S1 object contains both data and methods. S2 also both here. S3 also both. Yes. Okay. Now here, let us memory map of these objects here. Memory map. Sample S1 equals sample like this. S2 like this. How these things acquires memory? Let us see memory map. Memory map. Yes, here this is stack memory and heap memory. Already discussed about stack and heap. Stack, heap. Stack and heap. See, in this S1, S2, S their references. Like a array reference. Previous class, array A is reference, right? All the references stored in stack memory. Java references. S1 is the reference. S2 is the reference. S3 is the reference. All reference storing stack memory. So S1, S2, S3. Now in stack memory here. So first S1. 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 So here you see S1. S1. Okay. Here you see S1. S1 reference. S1. S1, right? S1. Okay, right? Next S2. On top of it, S2. Next one is S2. Next one is S2. Next one is S2. Next one is S2. Okay, right? Next one is S3. Next is S3. S1, S2, S3 like this. Yes, S1, S2, S3. So first S1, S2 and S3 like this. S1, S2, S3 are references. All the references stack memory. So first S1, see sample S1 equal new sample. Now what happens can new? It will create object for sample class. Creating object for sample class. Creating object for sample class. When object is created here, all the members of class acquires memory. When object is created, all the members, new will create object for the sample class. Okay. So once object is created, all the members of the class acquires memory. All the members of the class acquires memory. Yes, where this is. New always works in heap memory. New is for the runtime memory. New is to create allocate memory at runtime. New is always using for dynamic memory. Dynamic memory, dynamically allocating memory. See, dynamic memory always inside the heap area. Dynamic memory always inside the heap area. Heap is for the dynamic memory. New always working in the heap memory. Now what happens here? Now new, yes, it will create object instead of the heap memory. Say here object always goes to heap memory. Object is always in heap memory, but its reference is stack memory. Its reference in stack memory. Okay. Suppose address of this object is let us say 1000. Address of this object is 1000. That 1000 storing into this location. Yes, 1 second. See here this object new allocates memory for the entire class. Okay. When object is created, all the members of the class acquires memory. When object is created, all the members of the class acquires memory. All the members means like here they say all the members like they say A, B, data members and methods also. So first of all A and B data. Suppose A this is. Next B. Yes, variable A. Yes, A. Memory for A this is. Next memory for B. For A and B here. A. Yes. Memory for A. Next memory for B. After this, next set data method. For this also memory allocating set data. For this memory set data codes, that code acquires memory here. Next after display codes set data display here. Okay, now this can see this part connects data inside the A, this part connects for data inside B here, this part connects for set data method code. First statement, next statement, that method codes. Okay, it's a code. That set data code here. Next display. Yes, it's a display code. So when object is created here, all the members of the class acquires memory, including methods. Methods are also part of objects. After creating object here, address assigned to S1. See, S1 equal to new sample. S1 equal new sample. So new it will create objects. After creating object, address assigned to S1. Just creating objects and address assigned to S1. Okay. Now S1 contains what? Address of actual objects. This is the actual object. S1 contains what? Address of object. That means what is the S1 is a reference variable. That's it. What is the reference variable? Reference variable contains what? Address. Reference variable contains address. Okay, now S1 contains address of this object. Okay, right? Yes, next statement. S2 equal new sample. For S2 purpose, another object creates. Another object here. Another object. Okay, for S2. Yes, another object. Creating another object. Okay, suppose address of this is 2000. Another object creating. Yes, these are the same. A. Next B. Next same set data on display. Same set data display here also. Same here. Yes, data memory A here. Next B. Yes, like this. AB. Okay. Yes, this is for A. This space is for A. This space for B here. Next, set data display, set data display methods here. Set data display here. Set data display here, right? Now here this is here set data code. Next display code. Set data code. Next display code. This is complete object. Here this started stored into S2. S2. Right? Now S2 2000 reference is location. Okay. So when object is created, all the members of the class acquires memory. So object contains both data plus methods here. Both data and methods. Okay. Suppose this object traveling network, for example here, this object traveling network here. Whenever object is traveling network here, not only data here, even code also will travel. Suppose object traveling network here. Suppose object traveling network. So an object traveling network here, data plus code both will be traveling here. Both will be traveling here. Okay. So with data, code also will travel. So that means code also part of object here. So methods also part of object. When object is created, data and methods both acquires memory. When object is created, data and methods, all the members of the class. When object is created, all the members of the class acquires memory. Means data and methods both here. Data and methods. This is S1 objects, S2 objects. Similarly, S3 objects. Same. Okay. Yes. Let us go to documents. See public sample int AB. Yes. Int A float B. Yes. Both are data members or instance variables. These are data members or instance variables. Set data. Next display. These are the methods here. Yes. Methods. End of set data method. Display methods. Data member. It holds data of an item called as field of a record. Method. It defines about current state of object here. Methods are to perform some transactions and data. Methods to perform CRUD operations and data. CRUD. Yes, methods generally perform CRUD operations. Okay, CRUD operations. Methods to perform all the CRUD operations. Okay, like CRUD, create, read, update, delete. Creating new data, reading existing data, updating, modifying data, and deleting existing data. Right? So next, class members does not acquire memory without creating an object. Class members does not acquire memory without creating an object. Okay. So what is an object here? Object is an instance of the class or physical entity of the class. Physical entity. Object is a physical one. Class is a logical one. Yes. When object is created, all the members of the class acquires memory. So object is a collection of data and methods. Object contains both data and methods. It's a collection of data and methods. Okay. Yes, how to create object? Creating an object. Sample S1. S1 equals sample. It creates an object. Creating object like this. S1. Yes, what is S1 is reference, is not object. S1 just is reference of object here. S1 is a reference of sample objects, but not an object here. It's not an object here. Just reference. S1 equal new sample. Now this part is creating objects. It creates objects. New sample. It will create objects. Okay, right? Yes. Next, S2 equal new sample. S3 equal new sample. Now see that memory map of objects. Memory map. Memory map. This is stack. This is heap. Stack and heap. Stack S1, S2, and S3. Okay. Yes. Heap memory. Yes. Actual address. Actual memory, right? Heap contains object like this. A, B, set data display. Next, A, B, set data display. A, B, set data display, right? Like this. So this address stored into S1. This address into S2. This address into S3. So object always goes to heap memory. Always goes to heap memory. Object in the heap memory. Object is always in heap memory, but reference in stack memory. All the references storing in heap memory. Object is in stack memory. Sorry. All the references, they are referenced in stack memory. Stack contains all the references. Stack contains all the references. Heap contains objects. Heap contains object. Always object goes to heap memory. New always working in heap memory. New always working in heap memory. Yes. Yes. So this is about memory map. Next. Yes. After creating objects, next we should invoke the methods. S1 dot set data. Okay. S1 dot set data. Next, S1 dot distance. We have been working on this. S1 dot set data, S1 dot display, S1. See, set data. It's a method from the sample class. S1 set data. Set data. It's a method from the sample class. So throw the S1 objects. Next, display. It's a method from sample class. Okay. See, sample S1. S1 is sample. Now, what does it mean here? S1 dot set data. When invoking like this, S1, what's the type of S1? Sample. S1 dot set data. Since set data method is invoking on S1 objects, what is the type of S1? Sample class. That means set data is a method from sample class. Set data is a method from sample class. Next, display. It's invoking on S1, right? Invoking on S1. What's the type of S1? Yes, sample type. That means display is a method of sample class. See, if any method is invoking on the object here, if method invoking on the object here, that method must be a member of sample class. Okay. Yes. If method is invoking through the objects, that method must be a member of the same class here. Okay. Yes, on the same class method here. You can't invoke other class methods. Okay. So to invoke methods, first create object, invoke method. Next create object, invoke method like this. S1 dot set data, S1 dot display. Similarly here, other objects, S2 and S3. Yes, S2 dot set data, invoking on S2 objects, S2 dot display, invoking on S2 object here. Next S3 dot set data, S3 dot display. That's it here. Okay. So the S1 on S1 object invoking these two methods, on S2 object invoking these two methods, on S3 object invoking these two methods. Okay. So this is defining a class. Next, creating object, invoking methods. Right? Okay. Yes. On this, some example we should discuss. Okay. Yes, some examples. Tomorrow we'll start examples on this. Right? Yes. Once, yes, one or two examples discussed, you can understand very clearly. Once some examples, 2 or 3 examples completed here, you can understand very clearly OOPS concept. Okay, that initial, what is object exactly, how to invoke methods. Okay, next, what's the purpose of invoking methods? What's the purpose of methods? What's the purpose of creating object? And all the things you can understand here. Okay, I think tomorrow class it will be clear. Today may be a little bit confusion, but tomorrow class you can understand very clearly. Right? Yes. Any doubts? If no doubts, let us wind up session for today. No doubts? Yes, let us wind up. Right. Yeah. Thank you. See you tomorrow.